Problem of the day number 7. So this is an application of all the different exponent rules. And while it might look a little bit intimidating at first glance, my advice is that you just take things one thing at a time, and then it's not nearly as difficult as it seems. Okay, so if we have an expression like this that they tell us to simplify and that our answer should only contain positive exponents, the first thing that I notice is this parentheses with an exponent of -4. Now remember, a negative exponent means that if it's in the numerator, you want to put it in the denominator. If the negative exponent was in the denominator, you want to put it in the numerator. So because this one's in the numerator, let's put it in the denominator, and then the exponent turns positive. So we still have the 2m to the -1 power, and we have the p cubed in the numerator. But now in the denominator, we still have the 2pq squared, and we also have the 2pm to the -1 power, q to the 0 power, all to the positive 4th power now. Okay, and remember, again, it turned positive because it was in the numerator before, and now it's in the denominator, and so the exponent turns positive. Okay, then again, I would focus on the exponent with the power of 4, and we can use a rule where we basically distribute the power of 4, okay? So again, in the numerator, we still have 2m to the -1 power, p cubed over, and we still have a 2pq squared, and 2 to the 4th power is just 2 times 2 times 2 times 2. 2 times 2 is 4, another 2 times 2 is 4, so together they give us 16. Okay, then we have p to the 4th power, m to the -4th power, and still q to the 0 power. And the reason for that is because when you have a power of a power, you're multiplying the exponents, right? So p to the 1st power times 4, it gives you p to the 4th power. M to the -1st power times 4, it gives you m to the -4th power. And q to the 0 power times 4, 0 times anything is still 0. Okay, then now that I don't have any more exponents left, I would focus on one thing at a time. So for me, I always focus on the coefficients first, right? So we have a 2 on top here, a 2 on bottom here, and we have a 16 here. So I would simplify before multiplying. So this 2 and this 2 cancel out. And now the only number we're left with is only a 16 in the denominator. So we have a 16 in the denominator still. Then let's focus on the variables one at a time. So typically I would just go in alphabetical order. Okay, so let's start with m. Okay, so I have an m to the -1st power here and an m to the -4th power here. So that means that this m to the -4th power is going to move to the top. And so we have m to the 4th on top, and we have m to the -1st power on top here. So we're going to move this one to the bottom. So we have m to the positive 1st power on bottom, and then we simplify. And m to the 4th really means that you have m times m times m times m. M to the 1st power means you have m on the bottom. So again, simplify. So that really means you have 3 more m's on top than on bottom. So we have m cubed in the numerator. Then let's look at the p's. So we have p cubed here, and we have a p here, and we have a p to the 4th here, okay? P times p to the 4th in the denominator gives you p to the 5th in the denominator. And then in the numerator, we still have p cubed. And again, let's just see where we have more p's and how many more. So that means that we have 2 more p's in the denominator. So that means that in the denominator, we have p squared. Then let's look at the q's. All right, so we have q squared here and q to the 0 power here. Remember, anything to the 0 power is going to be 1. So q to the 0 really means you can just ignore that because multiplying by 1 doesn't change anything. So the only q we really have is the q squared, and it's going to be in the denominator. So we have q squared. And now we can see that we have simplified everything, and all of our exponents are positive. Oops. And then that would be our final answer.